Hello, everybody. Today we'll start Chapter 3, Introduction to SQL Queries. This Chapter 3 will be done through 3 lectures, 6, 7, and 8. We'll start overview of the SQL query language, SQL data definition, basic query structures, additional basics operations, set operations, null values and its duplication and problems in the null values, aggregate functions, nested subqueries, queries inside the queries, modification of the database, very important this note. Okay, now let's start in the history of the SQL database. Started by IBM company. Okay, later they name it to structured query language. Later in 96, 99, 86, 89, 92, 2003, and so on. Okay, so the history of the SQL. SQL parts, it's very important here. We have inside SQL queries, we have DML language as chapter 2. Data manipulation language provides the ability to query information from the database and to insert tuples or rows into, or delete tuples from table, or modify rows in the database. So we'll learn DML language inside SQL. Also about the integrity, the efficiency, or satisfy of the table of the constraint of the table, like primary key, foreign key, and so on. So we'll use DDL language, data definition language. So inside SQL query, we'll use DML language and DDL language, the both languages. Includes commands for specifying integrity constraint. Later, we'll learn how to make view. View means whole query, using DDL also. Then transaction control includes commands for specifying the beginning and ending of any transaction we'll make. Lastly, embedded SQL and dynamic SQL. Define how SQL statements can be embedded within a host language. Host language means like C++, Python, and so on. Authorization includes commands for specifying access rights to relations and view, username, password, and so on and so on. Okay. Data definition language, the SQL DDL allows us to specify information about relation, including the schema for each relation, the type of values associated with each attribute or field or column, the integrity constraints, which attribute, which columns, or which field is primary key or foreign key, and so on. The set of indices to be maintained for each relation, like a pointer here, we'll see it later. Security and authorization information. And of course, the physical storage structure for each relation on disk. So we will begin in data definitions. We have char n. For each attribute, we must assign which data type for each attribute, for each field, for each column. So char n means fixed length character string, was used to specify length n, how many bit, okay? So, or sorry, how many characters. So fixed length. the char n is fixed length. The var char n, variable length character string, okay, maximum will be n. So the difference between char n and var char n is big difference, because char n, for each field we have, let's say n equal 10. Let's say n equal 20 or 10. 20. So if we define any attribute, any field, any column as char 20, means we must fix this 20 character and stored in the memory. So it takes more amount of data. Even you write any word like 4 characters or 5 characters. So it will reserve for you 20 characters, even you write 4 or 3 or 5 characters. Whereas var char n, the same n20, here we have dynamic lengths, variable lengths. So if you write word inside varchar 20, like a word 5 character or 6 character, so in the memory will store only or preserve only 6 character, not the 20. So varchar is very dynamic, it's very useful, and to reserve amount space, to reduce amount space. Okay, integer, you know it, small integer 1 byte, integer 2 byte in the memory. Numeric p comma d, here we have example, it's fixed point number. It's like float, it's similar to float, but with fixed point number. Example here, if we make it a numeric parenthesis 3 comma 1, means we reserved 3 numbers or 3 digits, including 1 digits after the comma. Example here allows 44.5. So we have 3 digits, including after the decimal point 1 decimal point. So here we have 3 digits, total 3 digits, and inside the 3 digits we have 1 decimal point. Okay, it's not like Python, okay, or other language. When you define 3 comma 1 in Python and other higher language, they reserve the 3 digits for quotient and 1 digit for decimal number. So in Python and other high level language, if we write numeric 3 comma 1, they reserve 3 digits in the quotient part and 1 digit for the decimal part. But here in SQL database, SQL statement in any database, SQL statement in any database, when you define numeric 3 comma 1, means the whole number is 3 digits, not the quotient number. The whole number is 3 digits, including 1 in decimal point. Okay, because another language has different format. Also, we can define a real number, double precision. It's a floating number. Of course, we can also assign or data type float n. It's a float number. But in our experience in database, in companies programs for financial or accounting, for balance, money, invoices, customers, whatever, الحسابات الاكونت كذا، لقينا انه الفلوت عم بيعمل مشاكل. We have problems in floats. It's not accurate number will be displayed at the reports. We replaced float n always by numeric PD, always. So we use numeric PD. It's like a float. It's a float number, but it's a fixed number here. 5 will be, this 1 will be rounding up or rounding down. So we have fixed amount of or fixed number of digits. Okay, here you can put 2 or 3. Whereas in float number, infinite number after decimal point, infinite number, which make us in the program some errors in the numbers, output numbers. So replace float number in our database to numeric PD. Okay, so we use this as a float number. We specify how many display. In the financial, always we put it 2. Okay, 2 decimal after comma. Okay, any question here? This slide, any question? Good. Of course, we have more data will be covered, more data type will be covered in chapter 4. Now, let's start our queries. How to create table in the SQL statement. The command will be, the SQL command will be create space table space the name of the table R, the name of the table R, parentheses, close the parentheses, open and close the parentheses, A1, which means first column, space, its data type, comma, second column, second attribute, space, its data type, and so on and so on and so on. At the end of the attributes or the fields or the columns, after we put comma and we put here the integrity constraints. We'll see how. So R is the name of the relation or table. A1, AI will be the attributes, and DI will be its data type. Example, create table space instructor, open parenthesis, close parenthesis. First column will be ID, space, or tabular space, char5. Here the ID, they define it as a char5, 5 character, not as integer. Okay, so here in this example, the ID will be char, fixed by 5 character, comma, the second column, name, space, or tab, varchar 20. So it's variable length here, from 0 to 20. Department name, space, or tabular, varchar 20 also, comma, salary, space, numeric 8, comma 2. Here we have 6 before, 6 for digit or quotient part, 6 digit for quotient part, and 2 digit for decimal part. Okay, and comma. So, okay. Any question here? Good. Now, how to define integrity constraints inside the creation of the table. So we have 3 types of integrity constraint. Primary key, between parentheses, we put the column name, 1 or 2. Foreign keys, also we put attributes or fields name or columns name, and reference to any table. To which table? So foreign key will be referred to another table here. Okay, as you can see here, we cannot put at the same time the same column name at the same time primary key and foreign key. It's no way. We cannot. If we put the ID, let's say ID column as a primary, we cannot put at the same time ID as foreign key. It's impossible. Okay, and we have something like not null. Very important. So SQL prevents any update to the database that violates integrity constraint. Here we have not null. If we put a value, if we skip a value inside any field that will be not null, will give us error. We'll see it here. Example, The same creation table, we add this. Create table instructor, open parenthesis, close parenthesis. As you can see here, the same as before, but here we have not null. So name varchar 20 space not null means you must add anything inside name. You cannot leave it null value. You cannot skip this field. Okay, this is very important. Later we'll see the errors from null value. We have errors from null values. Okay, we'll see it later in our lab. So name must be include anything. Not null means you must put anything inside the name. After defining all the columns, all the attributes with their data type, comma, now you can specify which field here, which attribute is primary key. So primary key, primary space key space, between parentheses ID. So now we specify that the ID is primary key, comma. Also optional here, we can assign also which field is foreign key or fields. So foreign key, foreign space key, space of between parentheses the part name, references here s, always we put s, even one table, okay, s, references to another table called department, and put semicolon here. So if you have another foreign key, we put comma, and again foreign key, let's say salary, reference to salary table. What example? Okay. So we can add as we want foreign keys. Okay, we here, but only we have one primary key for this table. So one line for primary key. It can be ID comma name. It can be primary key, two fields. It can be, okay. It can be two, but usually only one attribute will be primary key. Okay. Okay for all. Any question here? Good. Okay. Now more relation definitions. Example here. Create table student. A student has ID, varchar 5, name the same, the part name, total credit. Here we have total credit, numeric 3.0, primary key ID, comma, foreign key depart name, references to department table, similar to instructor. Here we have another table called takes. Okay, takes. So create table takes. Okay, the same. ID, course ID, section ID, semester, year, grade. As you can see here, we have different IDs. So these are foreign keys. These are foreign keys. Okay. Varchar, 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 varchar. Here in the year, numeric 4, comma, 0. So here we have primary key. Here we have primary key, multiple primary key. ID, course ID, section ID, semester, and the year. Okay, this is primary key. Foreign key, ID reference to student. Okay, foreign key here again foreign key, course ID, section ID, semester, year, reference to another table called section. Here we have valuation about primary key is the same of the foreign key here. There are common attributes. This table, it's not a ordinary table. This table is for a relation called end-to-end relation. Later we'll see it. Okay, so this relation, this table is not a real table, is intermediate table. It's not essential table. Okay, because all the fields are not from this table. All the fields are not from this table. As you can see, ID from student table, course ID, section ID, semester ID, year from section table, as you can see. So the fields, all the fields here are not from the text field. It's intermediate table between two tables called in the relation many-to-many relation table, many-to-many relation table. That's why here the primary key and the foreign key, they have common attributes. That's why, because it's many-to-many relation. Okay, later in chapter 4 we'll focus on it. Okay, we'll focus how to build something like this. Okay, later. Now ignore it. Now ignore this. Also, if we want to create table course ID, var, title, depart name, credit. Primary key will be course ID. Foreign key will be depart name, reference to depart name. Okay, this is ordinary table. Okay, this is ordinary table. Okay, so now in this command, we create instructor table, student table, many to many tables here, special case, and course table. Okay. Okay. Any question for them? Easy or hard؟ شباب صبايا، صعب هين لهلا ماشي الحال؟
ايه دكتور تمام.
easy.
اكيد ايزي. اوكي يلا. طيب هلا now we want to update our table, our data. Okay, how we update our data? So by insert command, we can insert a row inside any table like this. Insert into space, insert space into space the table name, space values, between parentheses semicolon, we put the field values. This is ID character 5 between string, comma, name between single quote, comma, depart name, it's and var also between single quote, comma, salary, yearly salary will be number. Okay, the ID here in this example, the instructor ID is char5, it's not integer. Okay, that's why we put single quote here. So here in the SQL query or statement or command, we can add by hand manually. We can add it manually in this command. Insert to into table name, values, and list your values here. Okay, semicolon at the last. Okay, we can use insert. Also, we can delete rows. So if we want to remove all the rows from the students relation, just make this statement: delete space from student. So here, delete from table student will remove all the rows of the table student. So the table student will be empty. Okay, but if you want to delete the table itself, you cannot use delete. So the command delete will be only used for the data inside the table, the rows inside the table. Okay, if you want to delete the student table itself, called drop table. Okay, another command called drop table, this is mean delete the table. Delete only alone will remove or will delete only the data inside the table. So example here, drop space table space R. Now table R is removed from the database. Okay, so we have in SQL statements database delete command only for rows, drop command is for table. For drop table is for to delete the whole table. You can, if the data is a table, if the table few rows few data, you can drop the table from and بيمحي لنا التيبل مع الداتا تبعه اكيد. Okay, you can do it. Drop table will remove the table and its content, of course. Okay. Now, if you want to add or remove fields or columns to any table, we use alter. So command alter will be used like this: alter space table, table name, add column name, space data type. Example. Okay. A is the same of the attribute to be added to relation R, and D is the domain of A, data type. Of course, all existing tuples in the relation are assigned null as a value for the new attribute. Very important here. Here we have very important. نحن عندنا table. We have a table with data. There are data inside the table, and we want to add another field. Okay, for the next our data. So when you add this alter fields using alter, will be all the fields for all data will be null. Okay, so we have value null. Okay, later we will manipulate the null value and its error. Okay, if we want to remove a column from any table column, we call it like this. We write it like this: alter table, table name drop A. Here drop A means delete the column. Okay, drop A means delete the column A or fields or whatever. Okay, we don't have to put the data type because we delete it. We remove it from the table. Here, this command, as the state here, is not supported by many databases. Like in Oracle database, they don't have this. In Microsoft SQL database, of course, they have. In Microsoft Access, we'll test it tomorrow in the lab. Okay, we'll test this command if it supports Microsoft Access or not. This command: remove, add column, and remove column. Okay, first create a table, then add table, add column, and remove column. So we'll test it tomorrow in the lab in the Microsoft Access if we can drop a columns or remove a column. Okay, but it's supported by Microsoft SQL Server. Okay, now select a statement. A typical SQL query has a form. Select any attributes you want, any fields you want, from one table to table, free table, as many tables you want, where we have here predicate or condition. So the general form of SQL statement is, or select statement is, select one attribute or two attribute or three columns or four columns or all the columns from one table or two table or three tables or whatever many tables where we have conditions between them. Okay, so the result, always the result from any SQL query is a table, is only one relation, only one table. So whatever, how many here we have here, input m tables here, example, the output will be always the output will be one big table. Okay, this is very important. So the general form is select one attribute, two or three or n attributes from n tables or m tables where we have condition. So let's start. The select clauses list the attributes desired in the result of a query, which is equivalent to the projection operation of the relational algebra in chapter 2. Okay, it's equivalent. Select statement is equivalent to projection operation of the relation algebra in chapter 2. Example here, if you put only this, select name from instructor without where, without condition. So it's by projection, as you can remember in chapter 2. It's a pi. So will display only the name, a field name, for the whole name, the whole rows. The output will be all rows, only one column table called name from instructor table will display all the rows. Now, the advantage of SQL queries is it's not case sensitive. It's not case sensitive. Okay, small letters equal big letters. You can write whatever you want in the name, in the field name or instructor, or table name, table word, or field. So you can write small letter, capital letter, combined, all the same. This is not case sensitive. It's not case sensitive. This is something advantage. Okay, so SQL is not case sensitive. You can write whatever you want. Okay, SQL allows duplicates in relations as well as in query result. Means if you have repeated data in the table, SQL allows us to display it. Example, if you want to eliminate or remove the duplication rows, we must input another syntax called another keyword called distance after select. Example, find the department names of all instructors and remove duplication. So we put here select space distance department name from instructor. As you can see in the instructor table, we have many instructor names and the department name will be repeated for many of instructor names. So when we put select space distance means show me the department name field from instructor, okay, without repetition for the duplication of the department name. Okay, if we want the duplication field, so we put all, select all department name from instructor will give us here, select all will give us one column table called department name and the whole rows inside the instructor. Even we have repeated department name here. We have home physics, physics, finance, finance, and so on. If we put select distinct department name from instructor, the same output, but no duplication here. Okay, will be similar to select all from department name. Department name here is foreign key, so it's coming from table called department name. If we make a command select statement in department name, will be similar to select distance, will show us only the department names. Okay, any question here? I hope. Now we can select all attributes at the same time. Select star from instructor will give us the whole table. The whole table will give us the whole table, all the data with all the fields, columns, name. So we can select all from instructor. Okay, here special case. Here we have special case. We can write select without from, but it's special case. Okay, example here, select 437 single quote, but no table here. So it's a virtual table. Here we create a virtual table which is not included in our ARD diagram to be used in our calculation, our intermediate tables. Okay, result will be a table with one column and a single row with value 437. So it's a virtual cell. It's a cell, it's not a table here. One column, one row, it's a cell. So It's special case here. Okay. Also, we can give it name here. Select anything you want as any word. So will be then we rename it the table or the column. The same here. What is the difference here? Here we have select A between single quote from instructor. Here we overwrite all the data. So here in this special case, also special case, result is a table with one column and n rows, number of tuples in the instructor table, each row with value A. So we overwrite all the data in the table, okay, by A. This is our special cases, okay. Also, we can include in the select statement, we can include any condition we want, any arithmetic expression, plus, minus, star, division. We can include like something like this, divide by 12 or else or else, okay. So we'll stop here, okay. Tomorrow in the lab, we'll start Microsoft Access and use all these commands inside our lab tomorrow, okay. Any question for now? Any question for now? Good.